Michael here from Factbird, and now we're going to be talking about how you can get the most out of your data via operational excellence processes. It's one thing having your data in the Factbird system and being able to utilize that, but there's more to improving your production than just having data and graphs and visuals. There's levels. We have to start actually using this data, analyzing it, and making improvements based on what we're seeing. And the first level of that is tracking the flow. So this is what will happen when you first get your Factbird set up. You first start getting data into the system, especially if you're coming from a place where you haven't been gathering any production data. This is what we use a live graph for particularly. So we can see here, when is the production starting for the day? When are we finishing? How much have we produced? What's our tag time been? How many times have we been down today? How much downtime have we had? And what's the actual speed of our production been? Have we been running at the speed we know our production line can run at? Or have we been running slower? So with this basic bit of information, we can immediately start to identify some of the issues our lines are facing. Are we always starting later every day? Is our setup taking longer? Is our changeovers taking longer? Are we running slower than we could be? What's causing these basic issues at level 1? And then level 2 is registering stops and analyzing those stops. So in the system, you can either have your operators manually register the stop codes by clicking on the live graph, or you can have it automated if you use PLC integration. Basis for that is that we start getting in time accurate reason codes and comments from the operators so that we understand why the line has been down. But really, we want to analyze that and to understand the key issues for the production line. And we do that in our analytics tab. So using this tab, we can have a look and see how many times the line's been down, for what reasons the line's been down, and how much time it's actually cost the production. So now, when you start looking at this information, you can identify, what's my biggest issue? Are my operators taking too long to perform changeovers or cleaning? Are we scheduling things in at the wrong time so that they actually take longer due to breaks or due to lunch or due to other issues the line is experiencing? And initially, we have a Pareto graph for that. So you can see we have the different stop code categories here represented by color. And the main one we'll look at is our loss during operation. This is all of your unplanned downtime that your line experiences. We can see in the last week, this line's had 70 stops for unplanned reasons, costing about 1,027 minutes. But really, we want to dive in further into that information. So we can click on that and see in a Pareto graph again, the biggest issue in the last week was a product jam. So you can see here it's happened 30 times in a week, 361 minutes of downtime for that. So it's a very serious issue for this production line. And once we start to understand that, we can actually start to take action to help reduce and mitigate this problem. And we can dive into them further. So you can click on that product jam and see every time it's occurred, the comments your operators are making, how long it takes for the issue to resolve itself. And the best page, I think, for analyzing this, the scatter plot. So this one will give you an idea of how consistent this issue is on your production line. Because it's one thing saying, yes, you had 30 product jams in the last week, but if they all happened on Monday morning, is it a consistent issue this line experiences, or was it a bad day? So now we can see here, this is an issue that happens every single day pretty much. You can see how big it is, and you can see that it's fairly consistent. However, there was one very big stop at the start of the week. So using this, we can actually identify how serious these issues are at a more granular level. Should we be targeting them? How can we target them? Start those conversations up, because only then will you start to see that improvement in your production line. You can also use this to analyze the fixes you've put in place to solve these issues. So for example, if we knew on this production line, we had put in a fix on the 14th of May. We can see before that, there was lots of issues, lots of bigger issues. And now looking after that, we can see there's only been a few issues, all smaller time duration. And then we can keep using this to look at that for the next 2, 3, 4 weeks, and then actually understand, right, that fix we put in place worked, or it didn't. If the issue keeps persisting and keeps occurring, it's obviously not been fixed. And you can do this for all your different issues, whether it's changeovers, as I mentioned, cleaning, to understand maybe we need better operator training because the changeovers are just taking too long for what they should be. And once you actually start drilling down in our analytics tab and understanding those issues, then you can really start getting those gains and getting more value out of your production. Level 3 is next moving on to setting batch and shift targets and actually understanding on a product and shift level how our line's performing. Maybe product A runs at 80% efficiency, but product B runs at 50. And once we understand that, we can look into that and understand why. And then once we understand why, we can maybe plan our production better, because maybe it's a changeover or a setup issue. So if we set up and run our products in a certain order, we can mitigate that time that we're wasting for setups and changeovers. Maybe it's an operator training issue because a product requires specific quality checks or specific processes to be performed, and operators aren't quite as well trained in those as for the other product. Or maybe it's just simply that one product runs slower. So once we start to understand that and dive down into these issues, we can really start to target and plan our production to get it as efficient as possible. And to help with that, we have a batch and a shift dashboard as well. So here you can look at a shift dashboard and we can see over the course of a shift how much we expect our production line to actually produce and how much it has produced against that target. So not only can we see in real time if we're hitting that target or if we've fallen behind, we can also show that to our operators so that they get a boost on the line. They can see how they're doing in real time, understand that they're performing well, or if they've fallen behind on that target. And once we start looking at all this information, not only historically, but in real time, you can start to actually drive those improvements and see actual successes and get more value out of the production than you currently are. And that also comes into play with our OEE screen. So our OEE screen will look at the actual efficiency of the line. Once again, if we look at a week here, so we can actually start to display where the most value and the most percentage of your efficiency is being lost. Is it being lost for technical stops? Is it because the line is running slower? Is it for changeovers? Is it for cleaning? Is it for meetings? And once we start to understand that, we can actually target those areas and start to get the most value back again. Because if we can see here the line is actually running slower, losing us 16 hours worth of production, why was the line running slower? Once again, is it operator related? Is it machine related? Are we just overestimating our production lines and capabilities as well? And we've grouped this into a way with 4 different OEE scores to be able to help you analyze and understand better those issues. Because yes, we obviously lose 47 hours here for technical stops and speed loss, but maybe it's the changeovers we should be focusing on, and you can understand exactly how efficient your line is, taking those into account as well. Because if your operators need better training on changeovers, you could save hours of your production time just from having those better planned out or better training on those as well. Level 4 is then the next stage we're going to look at. And during this level, we want to actually start analyzing the scrap we're experiencing on the line and the defects. Because once we understand that, we can analyze, once again, linking into those product issues. Maybe there's certain quality controls or operator training that are causing us to lose more product. If once again, certain shifts experience more scrap. But also we can add in sensors to different points of the line where we know items get scrapped for specific reasons. And then you can see, right, I'm losing 50 products every shift for reason X. So maybe there's a major default or a major issue with operator training that we should look to address. And then once we have done that, we can reduce the amount of scrap we've had. And you can add as many of these scrap points as you like. So if you have different scrap issues, you can take that into account and try and narrow down the biggest causes of defects and rejects on your production line. Because even if those products are getting back into the production, there's still time allocated and lost due to rework. Or of course, if they're not, it's completely wasted product. And you can also add in manually how much scrap each batch you've had. So if you don't have the ability to add in more sensors onto your line to monitor that scrap, your operators can input, right, we ran batch X and we had 50 scrap, or we had 100 scrap. And you can also add in your quality controls in there so that when they're performing those, we can see, are they being passed? Have there been issues with the line? And once you link that as well with maybe analog signals or camera systems, you can then get even more information out of your line. We've had a lot of default problems on this shift, but the temperature was extremely high. Maybe that's linked. And you can use the camera system to analyze footage compared on the production line to when we had a lot of scrap and try and see, right, was there some issue there as well? And the final level, level 5, is starting to add in analog sensors so that we can monitor the equipment, so that we can actually perform preventative maintenance, because we can see, okay, the temperature or the vibrations of this machine are getting way too high. very consistently than what they normally are. And set alerts or alarms so that if the pressure, humidity, temperature, vibrations are too high, you can get text, email alerts to tell you so that we can mitigate that. Maybe turn off the machine, send maintenance to have a look at the issue. Because if that continues, we're going to have a major breakdown in the machines and we want to stop that from happening. You can also link that in as discussed with the quality checks. So if the humidity is too high, we get an alert to tell us, right, stop producing, reduce the amount of scrap. And all of these can be incorporated into the system to help you actually not just have data, but start to use it and utilize it to actually drive improvements. Because it's one thing having a fancy visualization and fancy dashboard showing you, yes, we're performing. But when you actually start taking that data, utilizing it, that's when you see those increases and those improvements in your production. And that's what we all want to see.